Let's take a look at another example here. I want to find all the relative and absolute extrema on the interval. And then I'm going to verify by making a graph. Okay, so the first thing I need to do is start off find the first derivative. So f prime of x is equal to 6x squared plus 2x minus 3. So I need to know when this thing is equal to 0. So I don't see this as quickly and easily factoring, so I'm going to fall back on the good old quadratic formula. So this will be 0 when, and just to remind you in case you don't remember the quadratic formula off the top of your head, it's x equals negative b plus or minus the square root of b squared minus 4ac divided by twice a, where a is the leading coefficient, the quadratic coefficient, b is the linear term, and c is the constant term. Okay, so what I have here is x is going to be equal to negative b, that's a negative 2, plus or minus the square root of 2 squared minus 4 times 6 times a negative 3 over 2 times 6, which equals, when you do all the arithmetic, negative 2 plus or minus the square root of 76 over 12. I can simplify this. This is negative 2 plus or minus 2 times the square root of 19 over 12. Obviously, I can factor a 2 out, do some cancellation. So this is negative 1 plus or minus the square root of 19 over, when that 2 comes out, cancels the 12, that'll give me 6. So by critical values, our x equals negative 1 minus root 19 over 6 and negative 1 plus root 19 over 6. So I have two critical values to check in this original function to figure out candidates in terms of, or try to figure out what the absolute, min, the maxes are. These are candidates for the local mins and maxes. Okay, so I need to check my endpoints. So I need to find f of negative 3. See, here's my endpoints. Here's the first one. F of negative 3, when I put 3 into this function, evaluate it, I get negative 37. F of 7 is 713. So there's my two endpoints. And now I need to check the critical values. So f of negative 1 minus root 19 over 6. Obviously, we're going to go for a calculator on that one and get a quick approximation. That's approximately equal to 1.0522. And f of negative 1 plus root 19 over 6. Again, with a calculator, that's approximately negative 2.015. So here's my absolute min. Here's my absolute max. And now I need to figure out whether these candidates for local mins and maxes really are local mins and maxes or not. So these critical values right here, when you put these into a calculator to get decimal approximations so you get an idea where you're at, you get a negative 0.8931 and a positive 0.5598. I should say approximate because obviously those are approximations. So I'm going to set up my chart like I would normally do, negative 0.8931, and over here is 0.5598. And that I'm interested in is what the first derivative is doing. So I need a number less than a negative 0.89 that is in my interval. So I would use like negative 1. And when I evaluate the first derivative right here at that value, at negative 1, I end up with a positive number. Now in between these, 0 is a really likely candidate. And when I find f prime of 0, I get a negative number. And then bigger than 0.55, how about just 1? And f prime of 1 is a positive number. So what that tells me then is that I have a local maximum, because I went from positive to negative, at x equals negative 0.8931, which is really the negative of this root here, and a local minimum at x equals 0.5598, which is approximation for the positive of this root, which is this guy, and then the other was that guy. So let's go ahead and jump into Maple real quick and graph this and see if what we just came up with actually makes sense. So I'm going to tell Maple to plot, and I'm going to type in my function 2x cubed plus x squared minus 3x minus 1. And I'm only interested in the interval we're given. So x equals negative 3 to 7. And there's my interval. Now all the action is happening down here, which is where I can't see it because of this scale. I went way up to 700 plus. But it's pretty kind of clear to see that this is the absolute max and this is the absolute min. So I'm going to zoom in on this guy a little bit. I'm going to go from like negative 2 to maybe 2. And now I can see what's going on a little bit here. I can see that at the negative 0.8931, which was the negative 1 minus root 19 over 6, right there, I have a local max, just as I claimed I did. And then over here at negative 1 plus root 19 over 6, which is 0.5-ish, right in here, I do in fact have a local min. So what we did analytically, we just confirmed with the graph.